Hi, my name is Thaddeus Johnson, and I will be participating in Challenge 2009. I will be speaking to you briefly about continuity. A function is continuous when it is satisfied by all real numbers. Continuous functions don't have holes, they do not have asymptotes. I will be using limits to explain the continuity of different functions. For starters, we're going to take the function f of x. Now, f of x, the limit of f of x as x approaches a is only continuous if the limit of f of x as x approaches a is equal to f of a, or the function of a. If it is not equal, then the function is not continuous or discontinuous. Now, in order for f of x to be continuous, two things have to happen. The first thing is that the limit of f of x as x approaches a has to exist. If this does not exist, then the function has no continuity. That means that the limit of f of x as x approaches a from the right, as well as the limit of f of x as x approaches a from the left. In addition to the limit of f of x as x approaches a existing, it also has to equal the function f of a, as we stated earlier. Now, in order for the function to be discontinuous, I can't spell. The limit of the function of f of x as x approaches a does not exist, or if the limit of f of x as x approaches a exists, it does not equal the function f of a, as stated earlier as well. Some basic limit properties to show continuity. If f of x as well as g of x are both continuous at a, then f of x plus g of x is continuous at a. F of x times g of x is continuous at a. F of x divided by g of x is continuous at a, provided that g of a is not equal to 0 based on division by 0. If f of x is greater than or equal to 0, then the square root of f of x is continuous at a, or if g of x is greater than or equal to 0, then the square root of g of x is continuous at a. If f of x is continuous at a and g of x is continuous at f of a, then the composition of function g of f of x is continuous at a. All of these are continuous at a. For our example, here we have a simple function, f of x is equal to 2 if x is greater than 1, negative 2 if x is less than 1, and 2 if x equals 1. So if we set this up with the limits, we have the limit of f of x as x approaches 1 from the left is 2. The limit of f of x as x approaches 1 from the right is negative 2, and f of 1 is 2. Here we see that the limit as x approaches 1 from the left and the actual function f of 1, they are both equal, but the limit as x approaches 1 from the right is not equal, which leads us to conclude that this function is discontinuous.